so my nose is all red. Okay. Okay, number 4. What requirements need to be checked when performing a ANOVA hypothesis test? Check all that apply.
I think all apply.
Sample means are all positive. It only has 2.
Not. We don't
I think,
have.
wait a minute.
Only the p-value, no, will be positive.
Variance. Requirements to check. All samples are from a simple random sample. The samples are independent. And the populations have the same variance.
Only the last one, do you think?
Sample means are all positive. Data in each group are normally distributed. Oh, no, data in each group are normally distributed for each group, yeah. So it's the last 2. I don't think the sample means are all positive. I don't know that that's one of them. It says they're independent, but.
When you have the graphic, all the data will be in the right side.
Yes, the right skewed.
But probably it's for p-value, no? Or for the t-score. The t-value.
Well, it's an F-score. For ANOVA. Yeah.
Okay. It's F-score. Okay.
Okay. So I think it's just those 2.
Last 2. Okay, let's try last 2. Okay, question 5. To check if each group is normally distributed to the following, it's the last one. Construct a Kiki plot for each group.
Yep.
Number 6. You read.
Number 6. We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. Largest sample mean is less than 2 times the smallest sample mean. Each group has the same sample size. So I think it's the largest variance is less than
2 times the smallest sample mean. This one, the third one.
But it's the variance I think that we have to look for, because according to my notes, it says the populations have the same variance, and it says check if the largest variance is no more than 4 times the smallest variance.
Okay. Okay. The sample variance for each group is smaller than the sample mean, not this one. The largest variance is less than 4 times the smallest variance. This one is, yeah.
Yeah, the largest variance is less than 4 times the smallest variance.
Actually, I learned from the video that it should be like 2 times.
Oh, yeah. So I asked
2 times.
I asked the teacher about that, and he said if you don't have the variance, you can always just square the standard deviation, and it would be 2 times the standard deviation. So Yeah, that's what they were doing, was the 2 times.
Okay.
So.
Okay, question 7. It's my turn. An ANOVA hypothesis test is equivalent to conducting independent two-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? I think it will be 6.
Yeah,
Because we'll have
because it would be
1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4.
yeah, 1 and 2, 1 and 3, 1 and 4, 2
and
and
3,
2
and
and
4,
4,
and
3 and 4. So 6. Yes, you're right.
Okay. Your turn.
The data in soccer shoes, do I still have that one up? Yep, was collected to help determine how the design of the soccer shoes affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, and E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10, is it millimeters away, from the target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller numbers are more accurate. Use this scenario to answer the next 5 questions. Okay.
Do we have to open this soccer shoes XLX?
The data file, yeah. I've got it up if you want me to. Let me get back here and I'll share my screen. If you want to see. Okay, let's go like this. Boop, where'd it go? Okay. So it's asking us for the next
5 questions.
What is the minimum smallest variance for the 6 groups?
I think we have 0 for yeah.
Do you see my variances over here?
Yeah,
like
I can see.
The smallest one is 27.208.
Why I have 0 here? Because
you have 0 in the variances?
Yeah. Okay, the data, let me see if we have the same data. Let me see here really fast. Okay, I have here for the D.
Oh, that's the last question. Thanks for coming, Herman.
Okay, well, how's it going, guys?
Good, how are you?
Good. Now that in this last video, the first of the 2 videos, they talked about kind of separating, how you were talking about the little flow chart of what we've learned and stuff.
Yeah.
And I'm just like, psh. If you were to ask me what the differences are, no chance I could tell you what the differences are. But if you put a few, like, it's going to be hard when we end up taking this test because it's not going to give us as much data. Well, it's not going to be in the same context. So we have to determine the context and then determine the right test to take. And that's going to be a bit challenging for me. So, okay. So what have you talked about? What are we doing?
We are on problem number 8.
Okay. On number 8.
Yeah, so we're just starting with an ANOVA test.
Okay.
So we're looking at, it's asking what the minimum variance for the 6 groups for the soccer shoes.
Okay, give me a second here then.
Yeah, you have
Okay.
to open
I had to drive home today instead of staying at work because we're going trick-or-treating and we're in charge of taking all the cousins and everyone else, and so it's okay, give me a sec. So yeah, for Halloween, hey, do you do anything for Halloween down there, Herman?
I already asked him and he said they don't have a holiday today.
We don't. I had when I was a missionary, but not now.
Is it do you even have like Dia dos Muertos or anything like that?
We have here, but it's not the same day.
Probably the same as Mexico either, right? Mexico, it's pretty big. Well, I think they have it on the 30th. So.
On Thursday, probably.
Maybe it might be the day after.
Yeah.
Maybe that's what it is. Okay. Okie doke. Sorry, give me a second here. The kids are running around like crazy now. So did Edgar say he's not meeting or what?
I haven't heard from him.
He emailed and said, "Are we meeting right now?"
Oh, maybe I should say yes.
I think he's coming.
He's coming.
Yeah. Okay.
This is 14, right? We're
yes.
at 14? Okay.
Yes.
Gosh, there's so much that we've studied so far. Okay, start quiz. Thanks for being patient, guys.
No problem.
Okay. We get up where I live, we get a lot of people that drive up to here to go trick-or-treating just because it's a nice area where the houses are close, you know? And so we get a lot of people that come up here. So we'll get like that whole family of Hispanics, well, Mexicans, and they'll come over. They're so funny. And like the grandma will dress up, you know? And she goes, trick or treat, trick or treat. She comes out. It's so funny.
I have to make homemade root beer for my children.
It's amazing. We have that for our ward party.
We're having friends over, so. Okay.
Okay, so you're doing number 3 right now?
Number 8.
Number 8? Oh, gosh. Okay.
We can go back really fast. We can start
really fast.
Number 3.
Yeah, let's do real quick. So number 3, in an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate that at least one mean is different from the others. False.
No, true.
Right?
It's true. This one.
True.
One mean is different from.
If only one mean is different, then we're gonna reject it.
Oh, right. Okay, I see. I always flip those backwards because of the word. Okay. Hey, Edgar.
Hi. Where are you, Greg? Are you in a hospital or is that?
Yeah, my home looks like a hospital. Those are pictures of my daughter. This is my bedroom.
We were waiting for you to start.
Sorry.
Edgar.
Sorry.
Okay, so Edgar, are you logged in?
I'm getting to the quiz.
We're going over. Herman and I are on number 8, but we're helping Greg with number 3. So.
Okay, but we didn't do very well number 1 and number 2. You can help us.
You're being funny.
Okay. I'm ready.
Okay.
So where are you? Number 3? Number 4, 5?
3.
Yes, I don't know. What is this? Okay.
True.
Give me a second.
What requirements need to be? Oh, are you on 4?
3.
Number 3. Okay, I'm ready. Sorry. So, in an ANOVA hypothesis test, we reject when there is sufficient evidence to indicate that at least one mean is different from the others. True, right?
Yep.
Sample means are all positive, and variances are equal in each group. Is that right? 1 and 3?
No, it's 2 and 3, right?
2 and 3. The sample means don't have to be all positive.
Hold on. I swear I read that. I swear I read that it can't be negative.
Yeah, but only the T1 when you put in the graphic.
Oh, so just the test statistic needs to be positive?
Yes. We believe so.
Yeah, we believe so.
Okay,
so I just remember the first data in each group are normally distributed and variances are equal in each group.
Yeah.
I don't remember the first
What
one.
I have is that all the samples are from a simple random sample and that the samples are independent and that the populations have the same variance, which is the largest variance is no more than 4 times the smallest variance, and that the data is normally distributed for each group.
Yes.
Okay.
Number 5.
Okay.
To check if each group is normally distributed, do the following. Construct a QQ plot for each group, I think.
Yeah.
Right?
Yes.
That's one.
Number 6.
We assume the variance in each group is the same if the following happens. We choose the second.
The largest variance.
The largest variance is less than 4 times the smallest variance.
I think
The
so.
largest. Okay.
Yes, I agree.
Number 7. Can you read?
Just a quick question. Just a quick question. Let me know if I'm right. I read that if the largest variance is 4 times, we cannot calculate the ANOVA, right? But less than 4 times is okay. But 4 is impossible. Is that right?
No.
Yeah.
No.
Or 4 is possible?
No, I don't know what you are talking about. But
okay, one of the requirements to compute an ANOVA is that the variances
no
are equal to each group.
Yeah.
And the largest variance should be less than 4 times. But if it's 4 times, we can calculate the ANOVA, right?
We reject. We have something. If it's less than, we reject.
Wasn't?
Yeah, I don't believe you can do one an ANOVA if that is so, if it's more than 4 times.
But if it's four times, we can or we can't.
I'm not sure. That's a good question. I can ask that.
But what I understood is you use this information to
So you're
to
saying
do
if it's exactly 4?
Uh-huh.
Yeah.
It's 4.
I think you're right. I think it's 4 and above you cannot, but less than 4 you can.
Okay, okay. Thank you.
Okay.
So number 7. An ANOVA hypothesis test is equivalent to conducting independent 2 sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples? What?
Okay, we choose 6 because we'll have. I can try to answer. We can have 1 and 2, 1 and 3, 1 and 4, 2 and.
So you're saying 1 and 2, 1 and 3, 1 and 4, 2 and 3,
2
2
and 4, 3 and 4.
3 and 4,
6.
6. Okay.
Yeah.
What about 4 and 3?
We already have 3 and 4. That's
Oh, right. Okay.
okay. Soccer shoes.
Soccer shoes.
Okay, I have a question for soccer shoes. What
Go ahead and ask them.
what are the data for the D?
The data for what?
The D, because I have in soccer here, I have A, B, C, D, and the stocks at the last.
Yeah.
And what are the data for D?
Let me look.
I have all 26, all of them.
So variable 1 starts with 35. Variable 2 starts with 30. Variable 3 starts with 25. Variable.
Probably I probably did something wrong here. I have 26 for all the Ds.
Oh, yeah, no. Here, let me share again and see if we can. Okay. It should look like this. Variable 1 starts with 35. Variable 2 starts with 30. Variable 3 starts with 25. Variable 4 starts with 26. Variable 5 starts with 43. And variable 6 starts with 34.
Okay. And I have to open it again because I have 26 for the soccer shoes in D. All of them are 26. Probably I did something here that changed the data.
Oh.
That's why my variance is minimum is 0 because I have this 26 here.
So 26 is the lowest?
No, I messed up
No.
here.
Oh no, hold on. What is this? What is the minimum variance for the 6 groups?
My minimum variance is 27.208.
Okay, let me open.
I see as variable 3, 27.208.
And I'm copying the data too.
Okay, I have to copy the data for D. I'm opening here again.
$53, $158.
Okay. So, variance 27.208.
Yes.
Okay, now I have the right data.
Papá, ¿qué haces? Que quiero jugar.
¿Qué pasó? ¿Qué pasó? Mande.
It's raining outside.
Oh no, it's raining.
Está lloviendo.
Yeah.
What is the minimum is
27.208, right? Or are we on number? Yeah.
okay, that one. I don't know how I had all the 26 in in this variable
She
4,
said something like it's
but
and there are clothing outside.
now it's okay.
Okay, so number 8 is 27.208, right?
Yes.
Yeah.
Okay. What is the maximum is
53.158.
Yes.
okay.
The test equal variance.
Okay, the maximum I had 47.24. The maximum.
47.
Now it's 40 40724.
53, right?
You're supposed to, it should be 53. It should be variance number 4.
Yeah, that's what I'm saying. 53, 158.
Yep.
Yeah, that's what I'm saying.
Okay.
Okay. Just kidding.
So the requirement is satisfied, right? Because the largest is not 4 times the smallest.
It's less than 4 times. It
Yes.
should be less than 4 times.
So the requirement is satisfied.
No, it's not.
See?
It's not, because if you do 27
There's nothing else.
times 4, it will be 80 something.
Yes, and the question is the test for equal variances is satisfied for this data. So that's
No,
true, right?
No, it's
Yes.
not.
Why not if the largest is less than 4 times?
No,
That's the requirement.
no, I'm confused. You are right. You are right.
Oh, okay. So it's less than 4 times, so
Okay.
it's true, right?
Okay. It's true. It's true.
No, it's
I was
satisfied.
confused.
Construct a QQ plot for each of the 6 samples.
What if we divide and
Oh, how can we construct this one? Because I was trying to find it in.
there is a document.
If you go to the one sample, I think, was it one sample? One of them, no, maybe it's not.
There is a document, quantitative descriptive statistics.
Yes, it will construct a, so which one do you guys want to do? Who's doing one?
I can do the first one. What? Second one.
Okay, Edgar's got the second one. Who's got the first one?
Yes.
Okay,
I'll do
what
the
are you
first one.
talking about? Sorry.
Which one do you have?
Cool.
Herman is doing the third one.
No,
Okay.
no.
And Greg.
In order to do a QQ plot, do we?
What?
I don't know how to do
Okay,
this.
how can you show us where?
Is it in the? Do we do it in Excel?
Yeah,
Yes. In
Yeah.
the
we do
book,
in Excel.
there is a link to find the document. In point 3.3 in the book, you will find a blue box, and in the blue box, I think almost at the end of the text, there is a link: quantitative, descriptive.
Quartile. What should we call it? Quotient, quartile.
Mhm. Bam, bam. What?
Nope. Okay.
Well, the second one is
Can
not
you
formally distributed.
can you share screen?
Yes. Let me see how to do that. Okay. Compartir screen. La pantalla completa, pantalla de la app. Convertir. Okay, can you see my screen? Can you see Greg on my screen?
Yep.
Joe's, I'm busy, pumpkin.
So here is the
No, guys, go.
what?
How do I get there?
Okay. See, this is the book in the right side of my
Yeah.
screen. Okay, can you see? This is the so 3.3, how to conduct an ANOVA test, and there is all those Greg
Hold
Nino.
on. Is that me? Is that me with that noise? Ah, it is me.
Is this lesson 14?
Sorry. Hold on.
Lesson 14.
Okay, so to conduct a click a no.
Okay. Quantitative inference procedures.
But that's
Or-
just to do the ANOVA.
No, the last one, using quantitative descriptive statistics. Can you see in my screen? Okay.
Oh, okay. I need you guys to go. Okay, so I can finish.
But Dad, it's
What?
Yeah. Okay. Click in there.
Hi.
Hola. ¿También hablan español?
Can you say vámonos? Okay, I need you guys to go, please. Okay.
Okay. Click there.
Yes, you click there and
Quantitative descriptive analysis or statistics. Joseph, go ahead, please.
yes.
The first one.
Where am I? Descriptive statistic. There we go.
Descriptive.
Gosh, dang, son of a- Mm. I am not
Okay.
happy.
It's opening.
Okay. Mine's not doing a QQ plot. Dang it.
This is the document, and here you paste the data, and this is the QQ plot. And as you can see, mine is not normally distributed.
Fan, please. Oh.
Yeah, the first one. Okay, let me.
So that is A, right? Did you do A?
Mine
Ooh,
is
mine is not.
is B,
Okay.
variable 2.
Okay, I got some different. I have quantitative descriptive statistic. Is that one right?
Yes.
And so there's a on the bottom there's a tab for it.
Four.
Okay, I want to pull this up and do this. So it's under main page, right? Under course resources, data files or Excel tools. No, not data files.
Yes, exactly.
Excel tools.
Okay, I knew it was one of the two. Now we're at quantitative descriptive statistics,
Yes.
right?
Yes.
Yeah.
Okay,
No, but-
señores. Okay.
Quantitative descriptive statistics, but my graph is different.
Yes, mine is not normal.
If you go down to the bottom where it says QQ under QQ plots and put the information in there, it will do a QQ plot. Yeah, see down here at the bottom where the tabs, it says histogram and descriptive statistics and then QQ plots and then version.
Ah, okay.
If you go into
Okay.
QQ plots.
Okay, okay. Now I have, I did, okay, I have to pass here.
The thing about this question is, construct a QQ plot for the 6 samples. Each of the samples are approximately normally based on what?
All of them are not approximately normal, I think.
Well, we already know that Edgar's wasn't.
Yeah, and mine wasn't either.
And mine wasn't.
So number 11 is false.
Let me put mine in. Maybe I'm normal, you guys.
Mine is,
Sorry, I'm not, but I'm just saying.
I did
Control
number
copy.
4.
I finally got it.
And I think each of them should be normal.
No, mine is completely abnormal. So,
Yeah.
okay.
So false, false, false.
False, 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 false.
Falso.
Okay.
So number 12 says perform an ANOVA test in SPSS. I don't know what is that. And
What- I know,
observe
right.
that the p-value is 0.01, no, 0.81.
81.
Then remove the SOX data and perform the test again. What is the p-value when we remove this data?
The SOX data. Okay.
We have to remove.
Okay. So
Test in SPS. What is SPSS?
it's a program for statistics. Now, what happens is it's all automated, and so we have this quantitative inference procedures that we use instead of that, or the quantitative descriptive statistics. Both of those we are using instead of the SPSS.
Yeah.
Oh, okay.
I got 0.2738.
That's software. Okay, I am just opening up my quantitative whatever. Oh, different.
So 0.30.
How long to open?
Right.
I got
I bet we're on.
0.278.
What's that?
The p-value.
And I got
So what's the p-value is 0.081. Remove the SOX data and perform the test again. What is the p-value when you remove the SOX data?
0.309.
So you remove. Can you zoom in there? Just make it a little bigger. Who's doing their screen share? Is that you, Tiffany?
Oh, mine is mine.
but I have a different number
Más grande.
for p-value.
Okay.
Yeah, my value is 0.309.
Why do I have 0.2738?
It's different in the southern hemisphere. That's why everything goes this way.
Do you guys have the same number?
So make sure that the SOX value that you had as variable 6.
Yeah,
That's
I delete all the
okay.
variables too.
Whoa, where'd you find this, buddy? That is
And I
sweet. Okay, I need you to let me Wyatt. They don't want to see your snake. Okay, he wants to show you the snake he found. It's a fake snake. It's a real snake. Okay, I need you to go, bud. Okay.
What did you get?
I got a fake snake. So, why do you think you guys are getting different results?
I don't know. Can you see mine? Yes, I remove variable 6 is SOX data, right?
Yeah.
So
I
I
remove
remove all of them, and I have 0.309.
Mine too.
I have
Herman, do you have the same information in the other variables?
Just double check like the first two numbers of all the other columns of variables to see if you got the same.
Find it?
No, I can't. It's like this is freaking weird.
I think we have three variables.
What?
No, I have for variable 2, the last one I have 33.789.
All right.
Okay, this is wrong probably.
Okay.
Let me variable 2. Do you all of you have 28? The last one.
Yep.
Yes, I have 28.
Okay. The problem is I had another number. Now I have 0.309.
Good.
Yay.
Yeah.
So 0.309.
Yep.
Okay. Question 13. The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left the F statistic?
Yes.
The right, right?
The right.
Right.
It's a right skewed. So it's to the right.
Okie dokie.
Wow. Hasta okie dokie.
Okie dokie.
Okie dokies. Okay, now hot dog nutrition. This should just say like 0. 0 nutrition, and then we can just move on.
Researchers. Okay. Number 14. Researchers at Consumer Reports analyzed 3 types of hot dogs. Ooh. Namely beef, poultry, and meat. Mostly pork and beef, but up to 15% poultry. Guess poultry. Poultry meat.
Poultry. Chicken.
Poultry is chicken.
Bird.
Chicken.
Chicken. Turkey.
Another word is
Oil.
fowl. Yeah.
Fowl.
Okay. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the file Shalala.
Great.
In the file Shalala, huh? Let's open that one. Okay.
Which one are we using?
The files.
So we have
Okay.
beef and then meat, which is
Beef,
probably
meat,
roadkill.
poultry. Okay.
Poultry.
I know.
Let's
Poultry.
examine.
Number 13, what was your answer for number 13?
Right.
Right?
Yes, our answer was right.
It was right.
Okay, that's right.
Let's examine the calories first. Construct a QQ plot. Calories for each 3 types of hot dogs. And compare the variance to determine if the assumptions to use the numbers are met.
So let's QQ plot.
Go.
B. Okay.
Okay, so hold up. So what are we comparing first here?
Calories?
Yes, calories.
Hold on.
Oops.
Okay, so let's examine the calories first. Okay. So do we do beef as number 1 then?
Beef calories.
Yeah, beef calories. Okay.
And my QQ plot is not normal, but I don't know if I'm right.
If I can. Hey, what you doing? Are you not gonna dress up right now? She's not dressing up yet. So we only have 3. Okay. I'm on my video chat. Okay. So in mine then, let's see, there we go.
Did we lock it?
Yes, please. Thanks, Suhan. Okay, so the question is, the assumptions have been met. It's safe to assume each group comes from a normally distributed population. So okay, so you're doing the 3 QQ plots in?
Yeah.
Is that what's going on?
And we could see that there is nothing normal in the QQ plot.
So then, la respuesta entonces, la respuesta.
Entonces.
Have not been
Down.
well in
Entonces, this is funny.
What, here in Spanish?
Yeah. Entonces.
Então falamos português.
So the distribution is not normal, but we need to know if the variances are equal or not to answer the question.
We have to put in the table there.
So the variances, the largest one is 636.846, and the smallest one is 508.6566.
Oh, so the answer would be the third one, right?
Yeah.
The assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal. Right?
Are the variance equal?
I think there is not 4 times of difference.
Right, you're right. Yeah.
So it's number 3.
Tienes razón. En esta ocasión, tienes razón. Okay. Number 15. Run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51. That F is 16.074 and that P is 0.000 with a level of significance equal to 0.05. What conclusion can you draw?
What?
2 and 5. Wait. 51. Yeah.
We did calories right now, right?
Okay. Yep.
The degrees of freedom are 2.
Yeah, that was calories that we ran. Okay. Not right now, Pumpkin.
Okay.
The mean number of calories. So the same would mean that the mean is 144 for those 3. The problem I have is I kept all the data in the other ones.
So we're rejecting the null, and we have sufficient evidence to say that the number of calories.
We have sufficient.
We have sufficient evidence to reject the claim that all 3 hot dogs have the same mean number of calories.
Yep.
Well, hold on.
No.
Determine the mean number of calories is the same for all 3 types of hot dogs.
So check it out. The variable 3, the mean is 118.
I will have to finish this later.
Okay.
We only got 4 more.
No,
okay.
4 more.
All right, Herman. Enjoy your next class. Thanks, bud.
Okay. Thank you.
Okay. So, with the level of significance of 0.05, what conclusion can you draw? Well, the p-value is less than the level of significance. So, in other words,
we can reject.
We reject the null hypothesis. And the null hypothesis is that all the calories are the same. Right? So then we have sufficient evidence to reject the claim that all 3 hot dogs have the same mean number of calories because the p-value is less. Now, it says determine if the mean number of calories is the same for all. It's not. If you look at variable 1, variable 2, the difference is very little. So do we have sufficient evidence to claim that hot dogs, or do we have sufficient evidence to claim that at least one hot dog type has a different mean? Is that all we have? Is it number 4?
At least one of the hot dog types has a different mean. At least one or all 3 hot dogs types?
Well, by different mean, they don't mean the exact.
At least one. Yes, I think it's at least one because yes, it's at least one.
Yeah. So the last one. Okay. Okay. Next is the sodium levels.
So now let's construct QQ plots of the sodium level. You should see that the QQ plot for poultry.
Poultry. It's poultry, not AU, poultry. No one will know if you say poultry. Everyone's going to be like, huh? What?
Poultry suggests a possible problem with the normality assumption. The small variance is the largest. Ooh. Poultry. So
Okay. Did you do some QQ plots?
yes, and they are not normal.
They're not normal. So the assumptions have been met. The assumptions have not been met. Assumptions have not been met. It's not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal. Let's check out the variances. The variances are 10,492, 8,812, and 7,180, which means they're not 4 times different.
So I think it's the last one.
Assumptions have not been met. It is not safe to assume each group comes from a normal, and we cannot assume that the variances are equal. How different do the variances have to be in order for us to know that to assume that they're equal or not equal?
Less than 4 times the smallest.
So it's definitely less than 4 times. So it should be the variances are equal then, right?
It's equal to 104, no, 10,000, 10,004. Oh, sí, it's equal. I thought it was 100,000, but it was 10,000.
Oh, right. Okay, so it's number 3 then. I see.
Yes. Number 3. Number 17. This despite a possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. What is the p-value for this test? Poultry. Okay.
Did you guys get 0.179?
Hold on just a second. I got 0.179. It says, decide to ANOVA determine the mean sodium level. My wife, instead of coming and talking to me, she's texting me. It's weird. For all 3 groups. What is the p-value for this test? Yeah, 0.179.
What?
Conclusion. Are you on number 18 or no?
Oh, for all 3 groups. Oh, yeah. I see the problem.
Can you draw about the mean sodium levels of the 3 types of hot dogs?
Oh.
So p-value is 0.179 and level of significance is 0.05. So we then
Reject or don't reject. We have insufficient evidence to show that.
So we failed to reject the null. We have sufficient evidence to claim that at least one hot dog type says no. We have sufficient evidence to claim that all 3 are the same. We have sufficient evidence to reject the claim that all 3, or we have sufficient evidence to claim that all 3 hot dog types are different. No, all we do is have sufficient evidence to reject the claim. No. Hold on a minute.
So what did you get for the p-value in the previous question?
It was 0.000.
0.0000?
But the hypothesis in here is that all 3 types have the same mean sodium level. We reject, that's the null hypothesis. We reject the null hypothesis because the p-value is higher than the level of significance, which is 0.05. So we do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean. That's worded so weird.
Yep.
We have sufficient evidence to claim that all 3 hot dog types have a different. That's what it is. No.
No, because we don't have sufficient evidence because we're rejecting.
Right. We have sufficient. We do not. So the only one that says we do not have sufficient evidence is the second one. But that's going backwards. I mean, like the way they word it is so dumb.
I know.
Okay. Well, you guys, who wants to submit first?
I will.
Well, wait. I'm trying to get a p-value for the
For the sodium
yes.
levels. Okay.
Did you enter in Did you enter in all the numbers, all the data?
I lost the document where I was computing the ANOVA,
Okay.
and I just found it.
It's 179.179.
0.179. So the conclusion was that we do not have sufficient evidence.
Yeah.
The second one, right?
Yeah.
Okay. Thank you. Save all responses. Yeah. Okay.
Oh, we got a QQ plot question wrong.
¿Cuál estuvo mal? 14. 14?
2 wrong.
14 and
11. The QQ plot questions. What you see in the QQ plot.
which of the samples are approximately normal based on what you see? ¿Por qué?
I don't get it.
All right, so I'm going to say the assumptions have not been met. Well, it's safe to assume each group comes from a normally distributed population. Wait. It's not safe to assume because the QQ plot was all over the place, right? And we can't assume the variances are equal. That's my guess is what it's going to have to be.
Yeah.
So I'm going to put, for 14, I'm putting the last one. And then 11, you said?
Yeah,
Then 11.
true.
So 11, we put, construct a QQ plot for each of the samples are approximately normal based on what you see in the QQ plots. And we put false, and it's true. Hold on a minute. Hold up. Hold up. What's going on here? Are we misreading the QQ plots?
What I understood is that if the QQ plot is normal, it should be close to the line.
That's
And
what I thought.
I saw
None of them are.
points everywhere. Hola.
Well, okay. I'm going to put true because I'm a cheater.
No, because after this analysis, you conclude that the.
Did you break your snake a little bit, bud?
The landowners did.
Oh, was that in their
Number
yard?
14, what is the actual answer then?
Just waiting in the dog.
I'll tell you. Give me a sec. I still got it wrong.
In 14?
So it's either. It's either the assumptions have been met, it's safe to assume both, or the assumptions have not been met, safe to assume one group is normal distributed, but we cannot assume the variances are equal.
I think it's that it was met. I think our QQ plots are screwed up.
I think so too. I think we're going to have to figure that out.
That's
Yeah.
probably.
I will ask on.
I know. You're not dressed.
Mhm.
Go get dressed in. Go get dressed in your Halloween costume, bud. Are you waiting for mom to do something? What's going on?
She's calling somebody.
Okay, buddy. Go see if you can help her. Then go. Are you gonna do the army guy thing again?
Yeah.
Okay. Well, I saved that one, and then you got 95%. So and that was easy because 11 was true or false. But we got to figure out what's going on with that. Hey, do any of you guys want to meet to kind of review stuff with the test?
I would
Go over
love,
stuff?
yeah.
Yeah, me too. Me too. Let's try. You know what? Let me talk to the boss lady here and see if we can do that. Maybe because the test is Saturday night. What time? When are you guys planning on taking it?
On Thursday.
Why? Yeah.
You can't take it on Thursday. It's not open on Thursday. Well,
It's open on Thursday, right?
The test? I don't know.
at like midnight.
Midnight? I thought it was Thursday, like something time.
I don't know. Okay. Well, I will. Let's figure something out by next Thursday. Okay. Well, pasado mañana, the day after tomorrow. Let's figure that out because I definitely want to review some stuff, just to go over. It's the stuff in principle. This last quiz, the chapter 13, I got a 92, but chapter 12, I got like a 62 on it, and I
Yes,
can't. What's that?
So did I.
Yes.
Drove me nuts.
Yep.
So
If you
I don't want to.
One
I don't
little thing wrong, it like throws
exactly.
half the problems off.
And that's the theory, understanding why. So let's figure that out. I mean, I think I'm okay with like 2 or 3 hours studying stuff. Like I'm totally okay with it. But I want to prepare some stuff beforehand, especially that flow chart. You know, even though we can have it, that doesn't help us understand it. We have to understand the theories and ideas behind it. So, anyways, okay, guys, I gotta run. I gotta go trick or treat with my kids. Vamos a hacer el trick or treat. That's what they say here.
Bye-bye.
The trick or treats, dulce o truco.
El trick or treat. Oh, I'll have ladies come in. They'll be like, trick or treat. They're like in their 70s, like a clown wig on. And I'm like, pues abuelita, vente para acá. Te doy todo.
Okay.
Come down. Okay. All right, guys. Hey, have a good night. We'll see you on Thursday, okay?
Okay.
See you.
Okay. Bye. He's crazy.